Hi, everybody. This is our activity on melting ice cubes. This is one of my favorite we do because it really encompasses a lot of different things about what we've been talking about with heat. And the first thing is, you can see we're going to be back with my thermometers again. Here I have two thermometers, thermometer 1 and thermometer 2, and I want to show you right now what those are attached to. They're attached to two items we've seen a number of times now. This is our metal conductor plate, which we know is a conductor. We've seen these a couple of times. This is our non-metal one that's an insulator. They're both right now at the same temperature on the diagram, so they are they're at room temperature, which we also saw when we did room temperature, that both of these were the same temperature. Now, I'll tell you one thing that is very weird here. They don't feel like they're the same temperature. That one right there, the metal one, feels a lot colder than that one to me. And we're going to find out why that is, why something can feel so much colder today, even if we know it's at the same temperature. And so anyway, here's what I'm going to be doing with these, and it's a really kind of a neat thing to do. I'm going to go ahead and put these on. This ring has really nothing to do with anything. It's just going to catch the water from the melting ice cubes. And I'm going to start here, go back here for just a second so you can see me start collecting the data on this. I'm going to hit the start button. And there's our lines right there at the top, and you can see they're right together because both those thermometers are reading right about 22.5 degrees, 22.6. They're very, very close together. So I'm going to come back over here because I want to be able to see these ice cubes. It's a pretty dramatic difference. So here are our two ice cubes. Here's the one on the insulator, and here's the one on our metal. Now, what you can see is you can see that ice cube on the metal platform is melting at a much quicker rate than the one that's on the insulator. And this can't be due to radiation because they're both getting hit with the lights in the room the exact same way. And it really can't be due to convection because they're also getting hit by the air in the room the exact same way. So this really is a conductor insulator kind of thing. And you can see the conductor right now is melting that ice cube much, much, much quicker than the other one. Now, I'm going to go over to, I'm going to come back to this, but I want to show you something that's very strange. Remember, we're taking the temperatures of these two blocks, and they started off at the same temperature. Well, guess what? They're not at the same temperature anymore. The blue line is our conductor, and you can see the one that is now melting the ice cube much quicker is colder. Now, that's very counterintuitive to think of why would it melt an ice cube faster if the platform is colder? Well, the reason is because think about where the heat is moving and what happens when the heat moves. This one is a conductor, which means the hot wants to go to cold. The cold is the ice cube. The warm is the platform. But because this is a conductor, it can move its heat into the ice cube much quicker than our insulator. And when heat leaves this platform, what's anything going to do when heat leaves it? Well, it's going to feel colder. If heat leaves your body, you feel cold and you put a coat on to try and give yourself an insulator so that the heat can't escape. And what's happening on this is the heat from that platform in our quickly melting ice cube is actually making it from the platform into the ice cube. And if heat's leaving the platform, it should get colder. But it's a very strange kind of an idea to think of the quicker melting ice cube being on a colder platform until you ask yourself, well, what's making it colder? Well, what's making it colder is it's a conductor and it can move its heat into the ice cube. And if it moves its heat into the ice cube is going to get warmer and melt. and the block is going to get colder because heat's leaving it. Now you can see on the non-metal one here, we don't even really have any signs of melting yet. The heat wants to go from the block into the ice cube, but it's an insulator, so it's having a hard time. And once again, its temperature is not really changing much at all. It dropped a little bit. The hot's trying to go to cold, but it's not easy to do because it's an insulator. Now, this is exactly why when we started, and these two, before we put the ice cubes on, and this block felt colder to me than this block, well, the reason is because if I'm touching these two things, then I'm the hot object. Heat wants to leave me. And if I touch the conductor, heat leaves my body easily. And if heat leaves my body, what sensation do I get? I get a sensation of being cold. If I touch an insulator, heat still wants to leave my body, but that doesn't move heat very well. So I feel a lot warmer because the heat's not moving out of my body. If it's the winter time and you're outside and you touch something that's metal, metal's a good conductor. That means you're the hot object, and if you're touching like a car, it's a good conductor, it's the cold object. Your hot in your body leaves to go to that cold, and it does so efficiently, and so you lose heat and you feel colder. Conversely, in the summertime, when you touch a car, now the car's actually warmer than you. Now the heat movement's going the other way. Now you're touching a hotter object than you, the heat's going to flow into you. Since it's a conductor, it can do so real easy. Now instead of losing heat, you're gaining heat, and you feel cold, or you feel very warm, backwards. At any rate, this is a wonderful little experiment, and you can see that the one on the insulator, the heat having a very hard time leaving the platform, and so really the platform temperature doesn't change because the amount of heat in it's pretty much the same. Boy, this one that melted fast, that platform got real cold because it was losing its heat. So that's our melting ice cubes demonstration. One of my favorites.